Chapter 2.5, Applications of Sets. So this will be our last chapter looking at sets. Essentially, we're going to take our Venn diagrams and now look at certain types of word problems that we can answer using our Venn diagrams. So we'll start with an application involving 2 sets and then work our way up to 3. So at Erie Community College, a survey was taken to determine where students studied on campus. Of those 250 surveyed, it was determined that 167 studied in the library, 138 studied in the cafeteria, and 75 studied in both the library and the cafeteria. Now, knowing all of this, we can answer several different questions about this. How many did not study in either the library or the cafeteria? How many studied in the library but not the cafeteria? How many studied in the cafeteria but not the library? How many studied in either the library or the cafeteria? So remember that it's actually very important to note how many total students there were, 250. And if we look at these numbers, we can't just add these up because that's going to add up to a lot more than 250 because there is some form of overlap here, right? So the overlap being this 75. That's the overlap between students studying in the library and the cafeteria. Also, there might be some who didn't study in either. So we need to figure out how can I actually find the proper numbers to answer these questions. Well, we can use our understanding of the union versus the intersection and drawing a Venn diagram to guide us. So if we call our first set L for library and C for cafeteria, and then we've got our universal set U is just everybody who was surveyed, we get the following. The cardinality of U is 250. There's 250 total people being surveyed. The cardinality of students studying in the library is 167. Cardinality of students studying in the cafeteria is 138. And the cardinality of L intersected with C, or students who study in both, is 75. So we're going to make a new type of Venn diagram here, where instead of placing actual elements, I'm going to just state their cardinalities in each area. So, when you read a Venn diagram where each portion of it just has a single number, it's very likely that that's the type of Venn diagram you're looking at, though it should specify. So, we'll say that the intersection is going to be 75. We always start from the intersection in questions like this, and I'll show why in a moment. But remember that I hinted when we talked about those 3-part Venn diagrams that the most intersected area, we want to work from there outward, essentially. So we're going to place a 75 in here. Now again, remember this represents the cardinality of the regions, not the elements. So there is no 75 in there, it's that there are 75 people in that area, in that region. Okay, so now how do I figure out the number that goes here? So you may be tempted to say it's 167, but remember our total cardinality, right? That we have 250 total, and if I add 167 to 75, I'm getting pretty close to 250. So when I add in 138, if I did this, I'm already over 250 people. That's a problem. So we need to figure out, how do I actually know how many are in this specific area? Because L is just people who study in the library. If they study in the library and the cafeteria, they're already accounted for. So we don't want to double count. Remember, think back to when we talked about the cardinality of a union and how we don't want to double count sections. That's what we have to worry about in questions like this. Don't double count. So in essence, what this means is the cardinality of all of L, this whole circle, has to equal 167. But the circle already has 75 in it, so what is left over? Solve for x. So in this case, we get 167 minus 75 is 92. And we're going to do the same thing to figure out the cardinality of this region here. We take the 138 the whole circle has to add up to 138, so that's 75 plus x is 138. Solve for x, we get that the cardinality of C, which is 138, minus 75 equals 63. So now these two add up to 138, these two add up to 167, so everything makes sense. But we're not done yet because there are still some students unaccounted for, at least maybe. To figure out whether that's true, we have to say this entire area is 250. So we have 92, 75, and 63. How much is that? What have we already accounted for and what's left over? So to figure that out, we take 250 minus all of this, and we're going to end up with 20 left over. So in the end, 20 plus 92 plus 75 plus 63 should equal 250. That's how you want to check your answer. Check by actually adding all the numbers you have and see that it actually adds up to the total cardinality of the universal set. If you get anything wrong, you'll see that it shouldn't add up. And that's an easy way to check yourself. Alright, so now let's go and answer each of these questions. How many did not study in either the library or the cafeteria? So not in the library or the cafeteria. The library or cafeteria is their union. So not is what's out here, which happens to be that 20. How many studied in the library but not the cafeteria means we're looking at the library circle, but ignoring this area. So now we get that 92. In the cafeteria but not the library, same argument. We start with the cafeteria circle, but we ignore that 75 because that's the 75 in common with the library. So we get 63. And how many studied in either the library or the cafeteria? Remember, or means union. So we're saying, how many studied in at least one of the two? Well, that's all of this. And so we add up these three numbers and we get 230. So that's how we can explore an application involving two sets. But we're going to, of course, have to expand this to what if it was three sets instead. It's going to be the very similar type of problem, but a lot more statements have to be made for us to fill it in. So, Liberty Travel surveyed 125 potential customers. The following information was obtained. 68 wished to travel to Hawaii, 53 to Vegas, 47 to Disney World, 34 to Hawaii and Vegas, 26 to Vegas and Disney World, 23 to Hawaii and Disney World, and 18 to all three. Alright, so once again, we always start from the inside out. So we're going to work our way from the most intersected region towards these regions, and then once we get those, we come together to get each of these, and then we can finally move outside. So this ordering matters. We need to fill the circles in as we go. Okay, so 18 wish to travel to all three. All three means that's region 5. So that's where we're going to start. We don't have to do any work to get region 5, it's simply 18. But we do have to do some work to get every other region. Don't just put the numbers. It's never going to just be the numbers after that. The only time you get to just plop in the number is that first region, the most intersected region. So to get, let's say we start with Hawaii and Vegas, right? So to get region 2, this is the intersection between Hawaii and Vegas, but without those 18 people. So Hawaii and Vegas is 34, but we need to remove the 18 we've already accounted for. So we get 34 minus 18 is 16. Similarly, region 6 over here, we're taking the intersection between Disney World and Vegas, which is the 26, but we have already accounted for 18 people. So together, 26 minus 18 is 8. once again, notice that 18 plus 8 is that total of 26. That's what you're looking for. And finally, region 4, we're going to take the 23 total in Hawaii and Disney World and remove the 18 once again that we've already accounted for. So that leaves us with 5. 5 plus 18 equals 23 total. So now we can move out once again. Now that we have both of these, we can move towards the outer part. So all of Hawaii is 68. We've already accounted for 16 plus 5 plus 18. So what's left over? 68 minus that sum ends up being 29. So all of this together should equal 68 if you're doing it correctly. Next, we go on to Las Vegas. Las Vegas should all add up to 53. 16 plus 18 plus 8 plus 11, that's 53. And then Disney World should all add up to 47. 5 plus 18 plus 8 plus 16, all of this adds up to 47. But we're not done yet. Don't forget there is this 8th region we have to deal with. So we need to go back and note that there were 125 customers total. There might be some who didn't want to go to any of these 3 places. So how do we figure out how many there were? To do that, what we're going to do is we're going to take all of this and remove it from the 125 people to see what's left over. Don't take these numbers and remove them, because then you'll have a very negative number and that won't make any sense. It has to be, we have to work from our Venn diagram. So 250 minus all of this should, or not 250, I apologize, 125 minus all of that should give us 22. 125 minus all of that added together, all of these numbers, equals 22. Now, if we add all of this together, that's 125, which is the total number surveyed. So we've accounted for everyone in the survey. And that, once again, is how you should be checking your answers, is look at the numbers in your Venn diagram, add them up. Do this before answering any questions about the Venn diagram. So, once we've noted that this does indeed add up to 125, we probably did it correctly, we can ask, how many did not wish to travel to any of these destinations? Well, didn't wish to travel to any means we're outside of Hawaii, Las Vegas, and Disney World. So we're over here. So that's the 22. How many wish to travel only to Hawaii? Only to Hawaii is right here because these have intersection. So that's 29. How many wish to travel to Disney World and Vegas but not Hawaii? So Disney World and Vegas is this area, but not Hawaii means we're ridding ourselves of those 18, leaving us with 8. Wish to travel to Disney World or Las Vegas, but not Hawaii. So Disney World or Las Vegas, but not to Hawaii, is going to be all 3 of these together, right? Or, we have to remember how or versus and works. So and gave us this area because we are combining the 2. We are in both Disney World and Las Vegas. But or means at least one of them. So those 16 people, they did want to go to Disney World or Hawaii. Disney World or Las Vegas. It just happened to be that they only wanted to go to Disney World. But that's still part of that or statement. Those 11 people only wanted to go to Las Vegas, but that is one of Disney World or Las Vegas, as long as we cut out the Hawaii ones. So adding those 3 together is 35. And finally, how many wish to travel to exactly one of these destinations? Well, exactly one are these 3 sections. So we take 29 plus 11 plus 16 equals 56. So coloring in this diagram as you go can be very helpful to helping you figure this out, but my best advice for answering these types of questions is, of course, A, you start from working furthest in out. If you try to work in a different direction, you will get the answers wrong, I promise. There's only really one way to do this, is you have to start from that 18 and work your way out, okay? the most intersected region outward. Make sure when you're done, these things actually add up as you would expect them to. Look at that 125. Make sure it makes sense. Don't forget the universal set might have some people in it that weren't accounted for in those subsets. That's one of the most common errors, is just to forget this. Maybe you do everything else right, but you forget to account for that number. So please don't forget that one. And that's about it. That's it for our exploration of sets. This is a very common type of problem, so make sure you understand how to recognize it. When you just have listed out numbers of people having combinations of things, that usually means this is the type of problem you're looking at. So pay attention to the structure of the problem and you'll be fine.